This is a short introduction to some of the most important behaviors of polynomials. If we have the function f of x equals x minus 3 times x plus 2 times x minus 5, in the first place, if we multiply that out, we're going to get an x cubed plus something times x squared plus something times x and so forth. That should be clear to you. And that's a cubic polynomial, a polynomial of degree 3 with leading term x cubed. Now, the question is, when is this polynomial going to give us 0? Where is the graph of this polynomial going to cross the x-axis? F of x is going to be 0 if x minus 3 is 0, so certainly if x is 3 we're going to get 0. If x plus 2 is 0 we're going to get 0, so x equals negative 2 would make that 0. And if x equals 5, that would make x minus 5 0, and the whole product would be 0. So that there are three ways to get 0. If any one of these factors is 0, then the whole multiplication will obviously be 0. And we have the three zeros. Negative 2. From x plus 2 we get negative 2 on this purple graph. And then plus 3 and plus 5 here and here. And so the purple graph corresponds to the function. Now, if you just think about it, if we add 10 onto the end of this and multiply it out, it's still going to be a cubic polynomial. Just that last number in the end is going to be different. Adding 10 here corresponds to raising all the y coordinates by 10, right? Because we're adding 10 to the y value. So if we raise all the y coordinates of this purple graph by 10, I haven't specified a scale here, that might give us the red graph. There's some number we could add here to move the purple graph up to the position of the red graph. So certainly we could get a cubic polynomial such that this dip doesn't cross the x-axis. And the cubic polynomial then has just one 0. If we add just the right number, we could raise the purple graph up to the green graph, where the graph just comes down and touches the x-axis only in one point but doesn't go through. And then of course we have a 0 here, so we have two zeros. A 0 here and a 0 here. Another thing we can note is that if we have three zeros, the graph is going to have a turning point. It's going to turn here, it's going to be coming up, increasing, now it's decreasing, and then another turning point where it's increasing again. So we have two turning points. And of course, if we have two turning points, then we can get a graph of this shape, and we can probably get three zeros out of it. Or at least we can manipulate the general class of graphs that have two turning points and obtain some graphs that do have three zeros, or two zeros, or just one. So we'll look at the turning points, and your text will tell you some things about turning points for polynomials, but it all comes down to the way the polynomials factor and how many zeros they have. We'll note that, for example, the polynomial you saw here, the green one, that only goes through the x-axis at one point, might factor like this, into x minus 3 times x squared plus 4x plus 90. This x squared plus 4x plus 90 is irreducible. If you set it equal to 0, the quadratic formula is going to tell you that you got a negative under the radical. So this can never be 0. It can never be 0, it means you can never factor this. It won't be written as a product of two linear terms, like this one was. So that f of x, if it's a cubic polynomial, could be a product of a linear term times an irreducible quadratic. It could be a product of three linear terms. Or it could be a product of three linear terms, two of which are the same. If you have three linear terms, like it was x minus 3 times x plus 2 times x plus 2, then at the x minus 3 0, the one that's or the x plus 2 0, the one that's repeated, that's where you're going to touch the x-axis. Now that would correspond to negative 2 over here, but we'll see all that behavior later.